Good morning, children. Today we will start with a new lesson, that is Unit 12, Atomic Structure from Chemistry. Now tell me, what can you see in this picture? Yes, periodic table. In this periodic table, you can see many small boxes, right? So, each box represents an element. For example, the first box shows H. So H is an element. What does this H means? So H is called hydrogen. So first box is hydrogen element. Likewise, each box shows an element representing the symbols. Here, totally 118 boxes are there. So, in periodic table, 118 elements are there, in which 92 elements occur in the nature and the remaining elements are synthesized in the laboratories. As I said, each box represents an element. So, each element is made up of atoms. Each element is made up of atoms. Where can we see the elements in our daily life? Yes, every substance in our surrounding is made up of elements. Every substance in our surrounding is made up of unique elements. For example, gold element means it is made up of gold atoms. If it is silver element means it is made up of silver atoms. Likewise, copper and iron, which are made up of that particular atoms. So each substance is made up of an element, but an element is made up of atoms. As we know that atoms are the building blocks of matter. Now we'll see what is an atom. First of all, the word atom is derived from the Greek word atomos. Atomos means smallest indivisible particles. Actually, atoms are minute particles. So, we cannot see in our naked eye, even through microscope. That's what atoms are, smallest indivisible particles. Now we will see who discovered an atom. First, Greek philosophers Democritus and Luciferus gave a basic idea about an atom. They said that if we divide matter continuously, at one stage we cannot be divided further. Is called atoms. After that, many scientists gave their ideas about an atom. We will see one by one. So, first we will see John Dalton's atom model. John Dalton's atom model. His period is from 1766 to 1844. He proposed an atom model in 1808. So we'll see what is said about an atom is the atom. First of all the matters are made up of extremely small particles called atoms. Secondly, atoms of same element are identical in all aspects, that is, size, shape, mass, and properties. Thirdly, atoms of different elements have different sizes, masses, and properties. Fourthly, atoms can neither be created nor be destroyed. Fifth one is atoms of different elements may combine to form molecules. For example, when hydrogen atom and oxygen atom combine to form a water molecule. What is the formula of water? Yes, H2O. So the last postulate of John Dalton's theory is an atom undergoes chemical reaction. So an atom is the smallest particle of matter that takes part in a chemical reaction. These are the postulates of Dalton's atomic theory. So Dalton's model of an atom is called billiard ball model. He said that the atom is uniform and a solid sphere. It had no internal structure and no charge. So it is called solid sphere model or bowling ball model. Now we will see what are the advantages and disadvantages of Dalton's atomic theory. First advantages, he explains most of the properties of gases and liquids. Secondly, he explains the law of chemical combination and the law of conservation of mass. Thirdly, he helps to recognize the molecular differences of elements and compounds. Next is disadvantages or limitations of Dalton's atomic theory. So first point is it is a smallest indivisible particle. So atom is no longer considered as the smallest indivisible particle. That is the main disadvantage. Secondly, atoms of the same element have different masses. Different masses means that is isotopes. Thirdly, different elements may have same masses, that is in isobars. Lastly, substances are made up of same kind of atoms may have different properties. For example, graphite and diamond are made up of carbon atoms only, but they differ in their properties. Next, we will see about J. Thomson's atom model. First of all, his full name is Joseph John Thomson, and his period is from 1856 to 1940. He is an English scientist and the discoverer of the electron. We will see later what is electron. He proposed this atom model in 1904. He proposed that the shape of an atom is a sphere and its radius is 10 to the power of minus 10 meter. So this is how Thomson proposed his atom model, as inside a sphere positive and negative charges are spread over there, like in a watermelon. That seeds represents that negative charges in an atom, and the red portion, that is edible part in a watermelon, represents the positive charges in an atom. Thomson's atom model was also called as the watermelon model or plum pudding model. So he assumed that the mass of an atom is uniformly distributed all over the atom. An atom is electrically neutral because Number of atoms and number of electrons are equal in an atom. I will see what are the limitations of this Thomson's atom model. So, his theory failed to explain how the positive charged sphere is shielded from the negatively charged electrons without getting neutralized. Secondly, his theory not explains about the neutron. So, we have seen John Dalton's atomic model, also called as billiard ball model. After that, J.J. Thomson's atom model, called plum pudding model or watermelon model, where the protons are positively charged particles and the electrons or negatively charged particles are spread over the sphere. Next, we will see what is Rutherford's atom model. So, what is said is that a nucleus which is positively charged is surrounded by negatively charged electrons. After that, Bohr's atom model was proposed by Bohr, in which he said that protons and neutrons combine to form a nucleus which is at the center of an atom, and the electrons are revolving around the nucleus in an electron orbit. So, proton as positively charged and electron as negative charge. Finally, neutron as no charge. So the next topic is fundamental particles. Fundamental particles, also called as subatomic particles. In this subatomic particles, proton, electron and neutron. These are called fundamental particles in an atom. So in an atom, protons and neutrons combine to form a nucleus, and electrons are revolving around the nucleus in an electron orbit. So first, discovery of electrons. Electrons were discovered by J.J. Thomson based on William Crookes' experiments. So William Crookes discovered the cathode rays while he was studying electrical discharges in gases. Later, J.J. Thomson discovered that these cathode rays are composed of negatively charged particles called electrons. This is how J.J. Thomson discovered the electrons. Here you can see the picture of William Crookes and J.J. Thomson. So, William Crookes, who discovered cathode rays, and with the help of Crookes' experiment, Thomson discovered the electrons. Now we will see about the discovery of cathode rays by William Crookes. So, cathode ray tube is a long glass tube filled with gas like hydrogen gas and sealed at both the ends. So, it consists of two metal plates connected with high voltage. These two metal plates are called electrodes, that is cathode, another one is anode. So, the electrode is connected to a negative terminal of the battery is called cathode, and the electrode which is connected to the positive terminal of the battery is called the anode, that is positive electrode. Side tube which is connected to a pump that is used to lower the pressure inside the discharge tube. So the rays obtained is called Crookes rays, or we can call it as cathode rays. So in this, the cathode is an electrode that is connected to the negative terminal of the battery. It is called negative electrode, and the anode electrode, which is connected to the positive terminal of the battery, is called positive electrode. So the rays obtained from this experiment is called Crookes rays or cathode rays. So this is the experimental setup of the emission of the electrons. Electrons means negatively charged particles, that is cathode rays. Here you can see that the electrons are strike on the fluorescent material. What is this fluorescent material? So fluorescent material is nothing but when invisible radiation falls on materials like zinc sulfide, they emit a visible light. These materials are called fluorescent materials. I repeat it. When invisible radiation falls on materials like zinc sulfide, they emit a visible light. So you can see that light. These materials are called fluorescent materials. So about this experiment is that when the high voltage of 10,000 volts is applied to the electrodes of discharge tube containing air or any gas at very low pressure, so a greenish glow is observed on the walls of the discharge tube behind anode. So some invisible rays coming from the cathode is called cathode rays, and they are named as electrons. Now we will see what are the properties of cathode rays. First of all, cathode rays travel in straight line from cathode towards anode. Secondly, cathode rays are made up of material particles which have mass and kinetic energy. Thirdly, cathode rays are deflected by the electric and magnetic fields because they are negatively charged particles. Cathode rays are negatively charged particles, so they are deflected by both electric and magnetic fields when we apply it. Next, the nature of the cathode rays does not depend on the nature of the gas that is filled inside the tube or the cathode, the electrode which we have used. This cathode rays, that is the negatively charged particle, it has mass is 9.1 into 10 to the power of minus 28 grams, and its charge is, because it is a negatively charged particle, so its charge is -1.